Okay, we're going to finish up lesson 3.1c. Number 8 says a health teacher is writing a test with 2 sections. The entire test is worth 40 points. He wants the questions in section A to be worth 2 points and the questions in section B to be 4 points each. Let X represent the number of questions in section A and Y represent the number of questions in section B. So part A says to write an equation that describes all of the different combinations of the number of questions in section A and B. So let's let section A equal X and section B questions equal Y. So the ones in section A are 2 points, so 2 times X, and the ones in section B are 4 points, and there's a total of 40 questions. Okay, so we're going to graph this equation to show all the possibilities possible. So first, we want to move that into slope-intercept form, and I'm going to find a little space somewhere to do that. So we have 2x plus 4y equals 40. I'm going to subtract 2x. So I have 4y equals negative 2x plus 40. I'm going to divide everything by 4. So then I have y equals negative 1/2 x plus 10. So let's look at our graph. So this is the number of questions in section A. This is the number of questions in section B. Okay, so this is 5, this is 10, these are 5s. Okay, so we're going to start with 10 questions, and then we're going to go down 1 over 2. So there's our graph. Okay, so highlight an ordered pair that falls on the line and explain what it represents. So let me get my highlighter. And I'm going to highlight this point. So it's point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4. This means there are 11 2-point questions and 4 4-point questions. So 11 questions in section A and 4 questions in section B. So question D says if you have 16 questions in section A, how many questions will you have in section B? So we're going to go over to here. Here's 15, 16 in A. We're going to follow it up till it hits the line. It hits the line at 2. So 2 questions in section B. If you have 8 questions with 4 points each, that's section B, how many questions will be 2 points each? So we're going to go here, I'm going to count up to 8 right here. We're going to go over to where it hits and follow that down, and that will be 4. So it's going to hit at 4 right here, 4. So there'll be 4 questions. Is it realistic for there to be 9 questions in section A? No, because you'd have 5.5 questions in section E, and you can't have half a question. All right. Let's go to number 9. The Hernandez family wants to eat out on Monday night. Salads are $8 and sandwiches are $6 each. They have a gift card for $42 and want to spend every dime of it. Let X represent the number of salads and Y represent the number of sandwiches. So write an equation that represents all the possible combinations of salads and sandwiches they can buy with $42. So the salads are $8, 8x plus $6 times y, or the number of sandwiches, and that equals 42. So we got to put this into slope-intercept form. Come down here. So I'm going to subtract 8x from both sides. So I have 6y equals negative 8x plus 42. I'm going to divide each side by 6. So I have y equals negative 4/3 x plus 7. I reduced negative 8/6 to lowest terms. Okay, so again, let's label by 5s. And then let's make this the number of salads and this the number of sandwiches. Okay, so we're going to start here at 7. We're going to go down 4 over 3. We'll be down here, down 4 over 3. What do the ordered pairs on the graph represent? All the different numbers of salads and sandwiches you can have for 42. All the different combinations. List the realistic combinations for that order. Mark the ordered pairs on the graph that represent these combinations. So you can get 7 sandwiches, and no salads. Or you can get 3 sandwiches and 3 salads. That's all the combinations that are realistic, because you can't really get a half a salad or a negative number of salads. So those are the only ones that would work here. All right. Number 10. The difference between Eugene's age and Wyatt's age is 5 years. Eugene is older than Wyatt. Let X represent Eugene's age and Y represent Wyatt's age. So Eugene is older. So if you take Eugene minus Wyatt, the difference is 5. There's your equation. So let's put this into slope-intercept form and graph it. All the different combinations. So I'm going to subtract x. I have negative y equals negative x plus 5. When I divide by negative 1, I have y equals x minus 5. So I'm going to start down here. So let's label 5, 10, 15, 20. And this is 5 down here, negative 5. And 0. So we're going to start at negative 5. And we're going to go up. The slope is 1. So like this. So there's our graph. So I forgot to label this. This is Eugene's age, the possibility. And this is Wyatt's age. So make an ordered pair on the graph that represents the ages of Eugene and Wyatt if Eugene is the same age as you. So here are all the possibilities. If you're 14, Wyatt is 9. If you're 13, Wyatt is 8. If you're 15, 10. And if you're 12, he's 7. If he was the same age as you. Why does the graph only include mainly in the first quadrant? Because you can't have a negative age. And that quadrant is all positives. Just a quick check-in, we're going to graph both of these. So we got to put them into slope-intercept form first. So I'm going to subtract x. So I have negative 3y equals negative x minus 9. I'm going to divide each side by negative 3. So I have y equals 1/3 x plus 3. So I'm going to start at 3, up 1 over 3. They're both positive. Up 1 over 3. Now I'm going to go the opposite way. Down 1, left 3. Down 1, left 3. There we go. Okay, let's get this one into slope-intercept form. I'm going to subtract 3x from both sides. So now I have negative 5y equals negative 3x plus 10. I'm going to divide each side by negative 5. So I have y equals positive 3/5 x, because I have two negatives, minus 2. So let's start at negative 2 on the y. I'm going to go up 3 over 5. Up 3 over 5. Now I'm going to go down 3, left 5, down 3, left 5. All right, that's it for this section.